Magnetic field due to toroid. A solenoid bent in the form of a ring is called toroid. It is torus, around which a large number of turns of a metallic wire is put. At point P here inside and point R outside, the magnetic field is zero. And at point Q, which lies in the core of the solenoid, is mu naught Ni. And now we are going to prove it. So we take cross-sectional view. So here we consider 3 Amperian loop, loop 1, which is in the open space, loop 2, that is within the core of toroid, and loop 3, which is outside. So let's consider them one by one. So for the point in the open space interior, for loop 1, suppose radius of this loop is R1, then length of this loop will be, suppose it is L, so it will be 2 pi R. Now there is no current inside it, so because current flows only within the core, here there is current, so I will be 0. Hence, if we apply Ampere's circuital law, so we can say that B1 times L must be equal to mu naught I. So this will give B1 equal to 0. Now we consider a point inside the toroid, that is, we consider the Amperian loop number 2. So for Amperian loop number 2, suppose radius is, say, capital R, straight line. So suppose this is capital R. So now we again find the length of this. So suppose this time we write its length of this ring as L1. So that will be equal to 2 pi R. And current enclosed by it is I, but there are n turns here. This is wire is going inside, here wire is coming outside. It means this tells the direction of current. So these wires. So here if wire is wound n times, so or we can say total number of turns equal to, suppose, capital N. So we can say that current will penetrate it Ni times. So if we apply Ampere's circuital law, so we will get B times L equal to mu naught I, but as I told you, we have to write current as Ni because n times it will circulate here. So B times L1, that is 2 pi R, equal to mu naught N I, or B equal to mu naught N divided by 2 pi R times I, but N upon 2 pi R is number of turns per unit length, so we can write it B equal to mu naught small n I. Now we consider this third ring or third Amperian loop. So in this Amperian loop, although we can take its radius as, suppose, R2, suppose this is R2. So length of this portion, suppose this is L2, it will be 2 pi R2. Since it has no current, so RHS in Ampere's circuital law, B into L equal to mu naught I will be 0, because there is no current here outside. Current flows only within the core. So again, RHS will be 0. So B times 2 pi R2 equal to mu naught into 0. That is B equal to 0. So what we have observed that inside the solenoid means here in the empty space or Amperian loop number 1 gives B equal to 0. Amperian loop third also gives B equal to 0. Only magnetic field exists inside the core of the toroid, and that is B equal to mu naught Ni. If you remember, this is the same value as we have obtained in case of solenoid. Now let's take some questions. Question number 1. A coil wrapped around a toroid has inner radius of 21 centimeter and outer radius as 25 centimeter. Now, if there are 800 turns and wire and sorry, if there are 800 turns of wire and current is 12 ampere, then what are the minimum and maximum values of magnetic field within the total line? So let's calculate. So suppose this is inner radius and this is outer radius of the solenoid. Suppose we take this as A and we take as, so maximum we will calculate here and minimum we will calculate here. So B maximum will be equal to mu naught Ni, which is equal to mu naught N divided by length of this first ring, that is 2 pi A times I. We put the values. Mu naught is 4 pi into 10 to the power minus 7. Number of turns are given as 800 divided by 2 pi into A. In our question, A is 21 centimeter. So we write this value here. So 0.21 and 2 pi A times I. Current is given as 12 amperes. So if we evaluate it, so we will get 9.2 into 10 to the power minus 3 Tesla. Now let's consider the minimum. So B minimum, when we take this outer radius, then denominator will increase. So value will decrease. So mu naught times N upon 2 pi B times I, same formula, mu naught Ni. So 4 pi into 10 to the power minus 7 times number of turns are 800 divided by 2 pi into B. This time it is 25 centimeter. So we write it 25 into 10 power minus 2, convert into meter, into current. Current is same, 12 ampere. So we will get 7.68 into 10 to the power minus 3 Tesla, or 7.68 millitesla. Now let's take another question. Question number 2. A toroid has inner radius of 20 centimeter and outer radius as 22 centimeter, around which 4200 turns of wire is wound. If the current in the wire is 10 ampere, then what is the magnetic field inside core of toroid, outside the toroid, and in the empty space surrounded by the toroid? Let's consider solution. As we know that in the empty space surrounded by toroid is inside here, field is 0, and suppose this is toroid. So magnetic field exists within the toroid only, and suppose we consider a point here. So this is P, this is Q, this is outside. So here outside the toroid, P will be 0. So answer of second part and third part is 0. So second and third will give 0. Now, in first case, we will get B equal to mu naught and I, and we can put the values. So for that, here we consider average radius. So R will be equal to 22 plus 20 divided by 2, that is 21 centimeter. This is average radius. So number of turns per unit length, let's find out. So 4200 turns are there, and length in this case will be 2 pi r. So we can write it 4200 divided by 2 times 2 pi times r. R is 0.21 from where 21 centimeter. So this will give 1000 upon pi per meter. So we put the values. B will be equal to mu naught 4 pi into 10 to the power minus 7 into n. We have got 1000 upon pi into current is given as 10 amperes. So our answer will be 0.04 Tesla. Thank you for watching.